Good day, viewers! For today's lesson, we're going to talk about coterminal angles and reference angles. A pair of coterminal angles may be positive or negative. If the terminal side of an angle rotates in a counterclockwise direction, we say that the angle has a positive measurement. But when it rotates in a clockwise direction, the angle measurement is negative. For example, if you have a given of 135 degrees, how would you find the two coterminal angles? First one is positive. 135 degrees plus 360 degrees is equals to 495 degrees. For the negative one, 135 degrees minus 360 degrees, which is equals to negative 225, as easy as that. Now for the reference angles. The positive acute angle formed between the terminal side of this angle and the x-axis is called its reference angle. If the given angle is found in quadrant 1, the reference angle is equal to the given angle. For example, if the given angle is 10 degrees, which is in quadrant 1, your reference angle would be also 10 degrees. Now, if the given angle is found in quadrant 2, the formula is 108 degrees minus x. For example, if you have the given angle of 150 degrees, 180 degrees minus 150 degrees, your reference angle would be 30 degrees. Now, if the given angle is found in quadrant 3, the formula is x minus 180 degrees. For example, if the given angle is 210, use the formula 210 degrees minus 180 degrees. Your reference angle would be 30 degrees. Now, if the given angle is found in quadrant 4, the formula is 360 degrees minus x. For example, if you have a given of 315 degrees, to find the reference angle, use the formula, which is 360 degrees minus 315 degrees. Your reference angle would be 45 degrees. That's all for today.
Hello everyone, I am Gion Perez and you are in this subject, pre-calculus. I will be teaching you today the unit circle, converting radian measure to degree measure and vice versa. First, we have to know the concepts and definition. 1 radian is the measure of an angle in standard position whose terminal side intercepts an arc of length r. Since the circumference of a circle is 2 pi r, then there are 2 pi's, meaning there are 2 radians in a full circle. 2 pi radians is equal to 360 degrees, meanwhile the pi radians is only equal to 180 degrees. There are only actually 2 formulas to use, and it is the degree to radian and radian to degree. The first one is actually easy, and you will only have to multiply the degree measure to pi over 180 degrees. And for the second version is the radian to degree. And you just have to actually reciprocal the two given. You will only have to make it multiply the radian measure times the 180 degrees over pi. For the examples, we have 4. And the first one is to convert radian to degree measure. So the example is pi over 2. So since it's a radian given, it means that you have to convert it to degree. So what you'll have to do is to rewrite the pi over 2 and multiply it to 180 degrees over pi. So a little tip for you all, which was also taught to us by our teacher, is to remember that the pi of the given from the whole equation should be multiplied to the opposite side. So meaning if the pi of the given is in the numerator, you have to multiply it to the opposite side of it. So meaning you'll have example the first one you'll have it multiplied to the pi which is in the denominator. So meaning you'll have to cancel it, you know. So what will you be doing next? You will have to take out the pi, since you're gonna be converting radian to degree. So it will be since you have taken out the pi, you will have to multiply the denominator of the first given, which is over 2, and multiply it to the numerator, which is 180 degrees. So what you will be doing, since the 180 over 2 will be divisible to 2, it means that you can actually divide it. So if you divide 180 degrees over 2, it will give you the answer of 90 degrees. And that's about it. That's the final answer for that first question. The second one would be the 20 degrees. So what will you be doing? Since you'll be converting degree measure to radian, you will have to pi over 180 degrees. So since the 20 degrees is divisible by 180, you will be dividing that, and you will be getting the answer of pi over 9. So you have learned how to convert the radian to degree and degree to radian measure. And that's about it actually. You just have to multiply 180 over pi or pi over 180. I hope that you learned something in this lesson, and I will be seeing you again. Thank you.
Hello, I'm Beni and I'm going to show you how to find the exact values of circular functions. And for that, you're going to be familiar with these triangles, the 30, 60, and 90 degree triangle, and the 45, 45, 90 degree triangle. And for a fact, we know that across 30 degree is 1, across 60 is root of 3, square root of 3, and across 90, which is the hypotenuse, is 2. And for the 45, 45, around the 45s, across the 45s are 1, and across 90, or the hypotenuse is square root of 2. So you also need to be familiar with the Sohcahtoa. Sohcahtoa, because these tell us the equation of for the sine, cosine, and tangent value. I mean the sine, cosine, and tangent ratio. So with that, let's try to find the value of sine 30. Sine 30 degrees, I mean. Okay. Knowing that sine equals opposite over hypotenuse, we can plot it in the triangle. The opposite of 30 degrees is 1, which means opposite 1, and the hypotenuse is 2, which means the sine of 30 degrees, the exact values of sine 30 degrees is 1/2, and we solved it. Let's try another example. Let's find the cosine of 5 pi over 6. And since the problem is in radian form, the first thing we gotta do is to convert the angle from radians to degrees. And to do that, from radians and degrees, we know that pi equals to 180 degrees. So we can simply exchange 5 times 180 degrees over 6. Or if you want to see the whole canceling, you can just do 5 pi over 6 times 180 degrees over pi. But it's the same thing since it's cancelled. You can see that pi and pi cancels. 180 divided by 6 equals 30 degrees times 5 equals 150. And it's the same, you can check. So we know that cosine of 5 pi over 6 is the same or equal to cosine of 150 degrees. Now, how do we evaluate cosine of 150 degrees since we don't have it in our two special triangles that I showed in the beginning? So the first thing, we can plot 150 degrees and create one of the two triangles from it. So let's plot 150 degrees. So we got our, let me do it better. I can't draw, excuse me. So we got that, and we can plot now from, we start from the positive to negative. So that's 90 and 180. So 150 should be around here. Now we can plot the angle, and 180 minus 150 equals 30. We got 30 degrees as our reference angle here. 30 degrees as a reference angle, so we can use it. With the quadrants, we also know that this is in quadrant 2, this is quadrant 1, 3, and 4. Now we can put these values depending on which quadrant. Since in quadrant 2, x and y, x is negative. We can see x is negative, so we know that this is square root of 3, so it's gonna be negative square root of 3. And then y is positive, so it's still gonna be 1, and the hypotenuse is still the same. Now we can find the values exchanging. So we have we know that cosine equals adjacent over hypotenuse. So we can what? Exchange the values. The adjacent of 30 degrees. The adjacent to 30 is square root of 3. In this case, negative square root of 3. And the hypotenuse is 2. So we have the value cosine of 30 degrees equals negative 3 over 2. And that is the exact value. And we solved it. Thank you.